stories about water and urban places. This is Ideanthro. Hey everyone, and welcome back to Ideanthro. Coming to you today from Caloundra South in southeast Queensland. What I'm going to show you today is a streetscape bioretention system with a subtle difference that I think has some real benefits if it's applied in the right situation for the right reasons. So, this is what this streetscape bioretention system looks like. Looks fairly standard, maybe looks a little bit big for a streetscape bioretention system. What's special about this is that the road that it drains has one-way crossfall. So instead of, say, a typical streetscape bioretention setup, like what we might have seen quite a little while ago when we met with Malcolm Eady and went out and had a look at Bell Vista, is the typical streetscape bioretention setup would be you get to an intersection like this and it's a T intersection and you've got three bioretention systems there, one on the top of the T and two on either of the sides. And you've got normal two-way crossfall roads and it's drained out like so. But this bioretention system here has a one-way crossfall road. And I can see two possible benefits for this, two possible situations, two possible reasons you want to apply it. The first one that seems really obvious and apparent here is if you have a footpath running through the area. So if you look closely here at this particular site, what you'll see is that on three of the sides of the street, because it's for T, right? You've got of the upper right of the T, you've got verge on either side, and you've also got a verge across the top of the T. That on the side of one of the uprights, the verge of one of the uprights, and across the top of the T, there are footpaths. And as you can surely imagine, trying to fit in a relatively narrow verge, both a bioretention system and a footpath, well, that's quite a challenge. And when people do try and do that, the outcomes often aren't particularly nice. They get all squeezed in with a retaining wall, like for example in this photograph that is just around the corner from where I am right now. But I can see how using this one-way crossfall road, what they've ended up doing, and they will have had to have pushed one of the alignment of one of these blocks around a little bit, I think, to make a little bit more space. But what they've done is they've managed to fit a bigger bioretention system on one corner without needing it to interface in any way with a footpath. So you've got two clear sides of the road with footpaths, and you've got one-way crossfall on this road here that gets into this bigger bioretention system, no interference with the footpath, no need for a retaining wall, everything works really smickly. That's one advantage. The other advantage of doing this that I can see comes from kind of the geometry and size relationship of bioretention systems. So with a streetscape bioretention system, given the topography of this land here, and there's lots of these systems around the place, the depth from the invert of the curb to the surface of the bioretention system is essentially the same on every single one of them, regardless of the size of the system. And if they all have the same grade of batter, that means that the distance from the edge of the filter media, so you got the filter media before it, oh there we go, filter media before it kicks up to the batter, the distance from the edge of the filter media to the top of the batter horizontally is always going to be the same, because if you have the same grade and you have the same drop, then the geometry of a triangle means the distance is always going to be the same. What happens is this, that if you have a really tiny little filter media area and then have these batters that go out a certain distance because of the geometry, and if you calculate the area of that and compare it to the total area, and then if you do the same task with a much bigger filter media area with the same distance batter going out because it's the same depth, what you'll find is that the ratio of filter media area to total bioretention area, including batters, changes. When you have a tiny little filter media area, the batters occupy a far larger proportion of the total area of the system. But of course, you don't get any more treatment for those batters. So what you have is a very space inefficient system, and therefore, because land costs money, a very costly to implement system. A benefit that I can see with this system that's actually behind me as we film, but this system on the screen now, is that by putting it on one side so that more water gets through it and we build a bigger system with bigger filter media area, but because it's still only the same depth, we get a better filter media to total area ratio. So therefore we get more filter media per meter squared of batter. Therefore we get a more cost-effective system. So I really like this. I'm not sure whether you could apply this in all situations. I'm not sure whether it's the be-all and end-all situation everywhere. But it's just an example of how there's little tweaks, little variations that you can do with streetscape bioretention system design to make it suit a site more appropriately. So often when we see bioretention systems that make absolutely no sense in the landscape and look terrible, it's not that they couldn't have got an okay outcome there, although some sites can be very difficult, but very often it's not that they couldn't have got a good outcome, it's just that they didn't get a very good outcome. So take it on board, have a think, enjoy it. If you want to come and see this site, as I said, it's at Caloundra South. There's a picture on the screen now of the street name. By all means, come and check it out, have a look, see what you think. Cool, have a good one. We'll see you next time.
Before you go, our best episodes come from your questions. This knowledge base, these discussions that are Ideanthro improve with your contribution. So if there's a topic, an idea, a concept that you would like us to explore, come and ask us. You know where to find us. www.ideanthro.com/contact. You can find us on Facebook, YouTube, LinkedIn, and that place you get your good podcasts from. You know where to find us. We look forward to hearing from you. We'll see you soon.